Hey guys, today we're going to talk about exponents, okay? So just to kind of give you a breakdown, when you have exponents, what it looks like. So if I have 3x squared, okay, certain things represent certain parts. So for example, the 3, which is the big number in front, represents the coefficient, okay? The x here, okay, represents what we like to call the base. And this little bitty 2 here we like to call is the actual exponent part. So these are parts that you guys need to make sure that you understand and know the names for. Zero exponents. Now zero exponents are quite common, or not really common, but we do have situations where we see them. Well, 4 raised to the 0 power. So if you had your calculator in class and I asked you to put 4 raised to the 0 power, you end up with the answer of 1. Okay? So what this basically is telling us that is it doesn't matter what you raise to the 0 power, it's always going to be 1. So even a letter raised to the 0 power, the answer is still going to be 1. So anytime you have a 0 as an exponent, it basically becomes the number 1. Now negative exponents are a little bit different. Okay, when we have negative exponents, the easiest way I can explain it is you want to move it from where it is. So if it's on the top of a fraction, right? So let's say my negative exponent is on the top of a fraction. That means I need to move it to the bottom. Well, let's say it's reversed. Let's say my negative exponent is on the bottom of the fraction. Well, then I have to move it to the top. Okay? So notice here, x to the negative 5th power doesn't look like a fraction, but we know how to make things look like a fraction. That's by putting it over 1. So notice, where is it? On the top or on the bottom? Hopefully you guys are saying that it's on the top, right? It's on the top of my fraction. So in order to do this, I have to move it to the bottom. Now when I move it to the bottom, it becomes positive. Well, I can't have nothing on top, so it has to be the number 1. And that would be the answer. So x to the negative 5th power is the same thing as saying 1 over 5 to the positive 5th power. Let's look at the second option. Notice, always check to see where is your negative exponent located. Notice here, it's on the bottom of our fraction. So if it's on the bottom of a fraction, then we need to move it to the top. When we move it to the top, it becomes positive. Okay, so I'm going to take that, move it to the top, so it becomes positive y to the 3rd power. And 1 goes there, but we know that would basically be the same thing as saying y to the 3rd power. Okay, we're going to do the problems that are not circled, all right? So you can actually try the ones that are circled on your own. Alright guys, so the first thing that we're going to do is talk about dividing. So notice these are all division problems, and I know they're division problems because I see those fraction bars. Okay, those fraction bars are key indicators that these are division problems. So the rule, okay, is basically that you have to subtract the exponents. So in other words, and I'll show you how to use the rule here, if I see this and I see that their bases are the same, which means the letters are the same, all I really have to do is say the exponents and subtract them from each other. So that would give me an answer then of that x 7 minus 2 to the 5th power. Now, another way that I can teach you to do this is called expansion, okay, by expanding. If I see x to the 7th power, that means that I have 7 x's. Divided by x to the 2nd power means that I have 2 x's. All I have to do here is cancel out an x on top for an x that I see on the bottom. Or in other words, it's basically like I'm subtracting. Notice I can't cancel out anything else because I don't have any more x's on the bottom. Well, what do I have left? 1, 2, 3, 4, 5 x's, so that's x to the 5th power. Alright, so let's look at the next one. First thing that I do notice about this next one is that I see a negative exponent. So remember what we talked about before. If you see a negative exponent, it needs to be moved moved either to the top or to the bottom, depending on where it starts. Right now, our negative exponent is on the bottom, so therefore that means I need to move it to the top. So I'm going to move this whole thing to the top. So we end up with, well, 6m to the third power doesn't change, right? But I move the m to the fifth power on top with it, and that's all over negative 2. So what we need to do is deal with these two numbers that we need to divide. 6 divided by 2 is, well, that's just positive 3. Okay, I know we haven't really talked about the rule yet for multiplying exponents, but I have 1, 2, 3 m's here, and 1, 2, 3, 4, 5 m's here, so I would have a total of 8 m's altogether. Let's look at number 11. Okay, same exact concept. Alright, let's say I need to do this by expansion. So I'm going to really write this all out, but I do want you guys to take a notice of something. There is this z to the 0 power. What's anything raised to the 0 power supposed to be? That's right, the number 1. Okay, so basically we get rid of that z to the 0 power and we turn it into the number 1. So like I said, I'm going to do this by expansion. So w to the 7th power, I'm going to draw out 7 w's, x, y, and then I have z to the 8th power, which means 8 z's. Okay, and that is all supposed to be divided by w to the 5th power, so I'm going to draw 5 w's, x squared, which is 2 x's, y to the 6th power, which is 6 y's, and z to the 0 became the number 1, so really there's nothing there. So let me go ahead and do that. And now I look to cancel. So I'm going to cancel out this w with that w, that one. So I'm canceling out 3, 4, 5 w's. I can cancel out 1x. I can cancel out 1y. And I can't cancel out any y or any z's because I don't have any on the bottom. So my answer is going to be whatever I have left. Okay, notice my answer is probably going to look like a fraction. What I have on top is 2w, so that's w squared. And I got z to the 8th power, all divided by, well, what do I have on the bottom? I have an x, and how many y's? 1, 2, 3, 4, 5 y's, y to the 5th power. So that would be the answer, and that's me doing this by expansion. Now I can show you if you did the shortcut way. Well, not really the shortcut way. And I think most of you are probably going to like this way better because it's easier. But remember, you could also just subtract the exponents for each individual letter and get the same answer. Notice here I have 12 and 13 circles, so that's for you guys to try on your own. Alright, now we're going to be multiplying like bases, okay? And the rule here is that whenever we see multiplication, we're supposed to add the exponent. So that's the shortcut if you can remember the rule, okay? So for example, if I look at this first one, I'll do it both ways. I have, basically what I'm saying is that there's my base, which is the same for both of them, so that's why I can add them. I'm just going to take 3 and add 3 to it, because both of the exponents are 3, and that would tell me that the answer is m to the 6th power. Or you can use expansion, which means I just write it out. M to the 3rd power means that I have 1, 2, 3 m's. M to the 3rd power again means that I have 1, 2, 3 m's. And if I add them up, right, count how many I have altogether, I have m to the 6th power. Notice either way I did it, still end up with the same answer. You guys can go ahead and try number 2. Let me help you out with one little thing though on number 2. Notice this is a negative exponent. So therefore that means that I have to take this negative exponent and move it from the top to the bottom. Notice I help make it look like a fraction so you can see that, right? It's on top, so I need to move it to the bottom. Alright, so what that means is I end up with really x to the 5th over x to the 2nd. Notice it becomes positive. So this problem actually just turned into a division problem. Okay, just wanted to help you with that first part. So let's look now at number 4. I can do it both ways, can add up, show you the shortcut. So I have A, and I notice if a letter doesn't have an exponent, it's always understood to be a 1, okay? Always understood to be a 1. So I have A, 1 plus 1, then there's a B, and that's 4 plus 2, and then I have a Y with just the 1, and that's it. So basically what I'm saying is that the answer is going to be A squared, B, 4 plus 2 is 6, and Y to the first power. Now let me show you by expanding. Okay, so if I expand the first parentheses, I have 1A, and then 1, 2, 3, 4 B's, times, again, 1A, B squared, which is 2 B's, and a Y. So again, let's count them all up. So let's count up my A's. I have 2A, so A squared. I have 1, 2, 3, 4, 5, 6 B's, and only 1 Y. So notice I get the exact same answer. Okay, exact same answer. 2 different ways of doing it. Figure out what way is easier for you to remember it. Okay, same idea here. Okay, but notice we got some numbers involved. What I always like to tell my students, which is you guys, is I always like to circle the coefficients and multiply them. We're not adding those, okay? We're multiplying those. 7 times 5 gives us 35, okay? So I know that's going to be my new coefficient. Now let's deal with the letters. I have x, right, times 1, 2, 3, 4, 5, 6, 7, okay? I have 3 x's here because it says x to the third power. I have 7 x's here because it says x to the 7th power. Well, how many x's do I have altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer is 35x to the 10th power. 6. I do notice one special thing. I see y to the 0 power. Remember the rule. If you see anything to the 0 power, it always becomes the number 1. So basically it's saying negative 2 times 1 times 4 y to the 4th. Alright, well we have 3 numbers here. So I'm going to circle all 3. 2 times 1 times 4, we can do mathematically, and that gives us negative 8. And notice the only letter that I have left is y to the 4th, so therefore I keep it. There's 4 y's. That is the answer. Let's look at number 8. Okay, it has 3 parts to it, so I'm going to expand it out. Okay, so I have negative 2 x squared xx times xy. That's already expanded for me. Notice those are little ones with it. And then the last part is 3, and then I have 10 x's. Okay. First thing I do, circle my coefficients because I need to actually multiply them. So it's negative 2 and 3. Negative 2 times 3 gives us negative 6. Now let's count up how many x's we have all together. 1, 2, 3, and I know there's 10, so that's x to the 13th power. And how many y's do I have? Just the 1. So therefore, that would be the answer for that problem. Alright, now we're going to be doing exponent to exponent. Okay, so notice in these situations, we have parentheses here, and there's an exponent outside of the parentheses. Well, what that means is that whatever is inside the parentheses is being multiplied that many times. So for example, on number 14, I have m to the 3rd power inside of these parentheses. Okay, now outside my parentheses is a little 3 as the exponent. So what it's telling me is that I'm taking what's inside my parentheses and I'm multiplying it 3 times. Okay, so this, we just kind of actually turn it into a problem of multiplication. Okay, I can expand this, or remember the rule, you just add the exponents. Okay, so I have m times m times m. Notice, count up, how many m's do we have altogether? 9. So that would be the answer. Now, if you want to use the rule, which the rule says that anytime you have exponent to exponent, you multiply the exponents, this is what it would look like. Okay, so I have m to the third. All I have to do is take the exponents and multiply them. Well, 3 times 3 gives me m to the 9th. Okay, but that's me knowing that the rule says to multiply exponents. A lot of us don't do a good job of memorizing rules, so that's why I like the expansion way better, because it's kind of foolproof. Let's look at 17. The first question you ask yourself is, what kind of problem is this? Is it multiplication? Is it division? Am I just adding or subtracting? Or is it exponent raised to an exponent? Hopefully you see that it's exponent raised to exponent because you see a little exponent outside of the parentheses. So I'm going to rewrite the problem, okay, so that I can understand it a little bit better. Now the question is, how many times am I multiplying what's inside of these parentheses? Hopefully you said 3 because that's the exponent on the outside. So that's 5x squared times 5x squared times 5x squared. Okay, no. Now, let me expand, okay? So I have 5x squared is x times 5, x times x, times 5, x times x. So let me circle my coefficients, and I need to multiply them. So 5 times 5 is 25. 25 times 5 is 125. How many x's do we have altogether? 1, 2, 3, 4, 5, 6. X to the 6th power. Remember, you can always use the rule if you remember it, okay? So technically, you could have just added up the exponents, which is basically what you do when you multiply. All right, now we're going to kind of put it all together. So a lot of different things happening in these problems. So let's look at 18. Notice you got to always look at what kind of problem you have. I know it's multiplication, but I also notice that I have exponent to exponent. Okay, so let me deal with this first exponent to exponent. So that part in parentheses, according to its exponent, which is 2, I'm going to multiply it twice. So let me rewrite it twice. 4x to the 5th times 4x to the 5th. Times, now let's look at the second part of the problem, which is over here. Now this parentheses is raised to the 3rd power, that's its exponent, so I have to write that part 3 times. Times 3x squared times 3x squared times 3x squared. Okay, now I can expand, right? 4x to the 5th, 1, 2, 3, 4, 5, times 4x to the 5th, 1, 2, 3, 4, 5, times 3x squared, times 3x squared, times 3x squared. Alright, circle the coefficients, which are my bigger numbers in front of the letter. And now let's see what we get when we multiply that. 4 times 4 times 3 times 3 times 3 is 432. Now let's count up how many x's we have all together. 5, that's 10, 11, 12, 13, 14, 15, 16. X to the 16th power. Alright, notice 19 you get to try on your own, and I want to point something out. I see x to the 0 power. So remember, what does that turn into? 3 times 1w squared, right? Which is all being raised to the 2nd power times 5x. Okay, so technically 3 times 1, though, you know, is 3w squared raised to the 2nd power times 5 times x. So go ahead and finish that one out. Make sure you pay attention. It's multiplication and exponent to exponent. Finding the area of the shaded figure. Notice, in order to find the area, we better know what the area formula is, which is written right there for us. Okay, length times the width, or length times the height, however you want to say it. Notice I have both of those pieces of information. Okay, my length my height. Okay, so we can easily do this because it's straightforward, it's multiplication. 2x squared times 3xy cubed. All right, well, let me expand. 2x squared is x times 3xy cubed, 1, 2, 3y's. Circle my coefficients. So 2 times 3 gives us a total of 6. How many x's do you see? 2 plus 1 gives me 3 x's, and there's only 3 y's. So therefore, that is the area for that shaded region. Notice you can try the next one as well on your own if you'd like. I'll kind of help you set it up. Help you set this up. So negative 5x squared times 3x plus y to the fourth. Notice this actually looks like a distribution problem. Okay, so just try it, see if you can handle it, and we'll work it out probably in class because I know this one's a little bit tougher. Same thing with this last one. We're going to try this one. We'll probably go over this one in class. I know it's a little tougher, but feel free to try it on your own. Notice I kind of give you, how to do it, guide you. So you can follow the directions here. You basically take the area of the big one, okay, which would mean that you're doing this times this, right? And then minus, hopefully you guys know means subtract, okay, the area of the small one, which is this times this, okay? Notice there's that a to the 0 power, which technically becomes the number 1. So really it's just 4 times 3a squared. And then you can get your answer that way. So try it on your own, see if you can handle it. If not, no big deal. We'll probably work this one out in class.